Hi, welcome. It's time for Physical Sciences. My name is Tinyiko Kosa. You call me TK. If you want to do that, it's acceptable. That's okay. And now, today, we are on lesson number 18. And what are we doing? Grade 10, we're going to look at mass conservation, or what we call conservation of atoms during chemical equations or chemical reactions. Grade 11, we're going to be looking at some acids and bases. And grade 12, we continue talking about that chemical equilibrium section. You are going to enjoy this lesson, I promise you. So stay there, stay tight, just watch the lesson, participate in it with me. When we do calculations, do your little calculation as well. Work with me, challenge me when sometimes maybe I don't get the answer right. You should be able to do so. I know you can interact with me just now, but you can write, you can say no. In your Facebook page, you can say, there was this thing here, I didn't get it right. We can talk there as well. Now, let's start it. Grade 10, conservation of atoms or conservation of mass. What is it all about? The number of atoms and the quantity of mass of substances remain constant during chemical reactions. So when reactions take place, remember when we have a chemical reaction, we've got reactants that interact with each other so that we can get a product. Now, when that process takes place, we are told, this principle says to us, the number of atoms you start with should be equal to the number of atoms you end up with. That is provided the reaction runs to completion. In the same way, if we don't want to talk about atoms, we can say the mass you start with your reactants is the mass that you're going to end up with when you get your product. Okay, that's what it is saying. Now, this is what we call the law of conservation of atoms or the law of conservation of mass. This is one of the reasons why we have to balance chemical equations. Because if chemical equations are not balanced, we would not be able to see that we're starting with so many atoms and we're ending up with that number of atoms. We're going to have a problem along the way, and this is because your products that are going to form have got their own special chemical formulae that identifies them. And for that reason, we need to see that if we started with this number of atoms for a particular substance or element, and yet in the product formed, we don't have that element as a diatomic molecule in the case of hydrogen or oxygen or any other substance, but we have it as just one H or one O. Now, how do we make sure that the number of atoms we started with is what we're ending up with? We do that by making sure that our chemical equations are balanced. So we're going to learn that as well today. Now, let's have a look. As an example, if you have got a reaction between hydrogen and oxygen, you will produce hydrogen oxide, or what is commonly known as water. Okay, H2O. Now, let's see if this equation here is balanced. 2 hydrogen atoms on the left, 2 on the right. We're fine so far. But when we look at oxygen, we've got O2, 2 atoms of oxygen on the left. We only have 1 on the right. Now there we have a problem. We need to balance the number of oxygen atoms from left to right. And what do? We come and put our balancing factor. And this is what we call the stoichiometric number, stoichiometric factor. That number is placed in front of that chemical formula. It is not, you don't come down here, for example, you don't come here and put your 2 there and say, I have balanced the number of oxygen atoms from left to right. Why? Because when you do that, you have changed the identity of that chemical substance. In this case, water. Water will always be H2O. It can't be H2O2. When you go to H2O2, you're now talking about a substance called hydrogen peroxide, which is not water. So you have changed the chemical identity. So you don't balance it by putting subscript numbers there. You put in a stoichiometric factor. How do you do that? You put that stoichiometric factor there, not there. Okay, so when you've done that, you have balanced the number of oxygen atoms from left to right. But by putting these 2 here, you have made the hydrogen atoms on the right to become 4, and yet you only have 2 on the left. What do? you put another 2 there, your stoichiometric factor, and that says 4 hydrogen atoms on the left, 4 on the right. 2 atoms of oxygen on the left and 2 on the right. Now, that was the atom conservation. Okay, can we also explain this in terms of mass? Yes, that is true. We can do it. How do we do that? You've got 2 of hydrogen molecules on the left, so you're going to have 2 there. The mass number of hydrogen is 1, so it's 2, this 2 here times 1, plus for oxygen, this 2 here times 16. This should give us 2 for oxygen, for hydrogen there, it's what? It's 2 into 1 plus 16 for oxygen. Remember that this 2 is for everything in there. That's why I used this big brackets here. So you've got 2 times 2, it's 4, plus 2 times 16, it's 32, equals, inside the brackets here, you've got 2 times 1 plus 16, it's 18. So you've got 2 into 18. Now 3 plus 32 is 36. 2 times 18 is 36. So you can see that even with the mass, there is conservation happening there. You can try it with any other chemical equation that you can come across. Once it's well balanced, you can actually show this. See you in the next section.